Hello everyone and welcome to Programming Journey. I'm your host Konstantinas, and in this video we'll be exploring Rust standard library. Before we delve into the specific modules of the standard library, let's understand its purpose and importance. The standard library is bundled with every Rust installation and serves as a core resource for developers. It provides essential data structures, input-output operations, error handling mechanisms, and more. Leveraging the standard library can significantly streamline your development process and enhance the quality of your Rust programs. The std module includes fundamental data types such as strings, vectors, hash maps, and more, which are extensively used in Rust programs. Let's explore some of these. Let's start with the string type. It is used for representing text in Rust. The interesting part is that you can use string without explicitly importing it, as it is part of Rust Prelude. In this code, we have a string literal greeting and create a mutable string called myString by using the from method. We then append more text to myString using the pushStr method, and finally print it out. Next, let's talk about the vec type. It is a dynamic array that allows you to store and manipulate collections of elements. Similar to string, you can also use vec without explicitly importing it. In this code, we create an empty vec called numbers using the vec_new function. We then add elements to the vector using the push method. Finally, we iterate over the vector using a for loop. In our final data types example, we use the hash map type from the std collections module to store user information. We insert key value pairs representing names and ages into the hash map. With the get method, we can retrieve the age of a specific user. Additionally, the code demonstrates how to iterate over the hash map and print the names and ages of all users. As you can see, the std module provides a wide range of data types, including strings, vectors, hash maps, and more. These types offer efficient and convenient ways to manipulate and organize data in your Rust programs. The stdfs module provides functionalities for working with the file system. You can use it to read and write to files, create directories, manage permissions, and more. Let's see an example of reading from a file. In this code, we open a file using file open and read its contents into a string using read_to_string. The stdfs module provides a rich set of functions and types for file I/O operations, allowing you to work with files seamlessly in Rust. In Rust, we can read input to standard in and print to standard out using the functions on the screen. These functions return a handle to the standard in and standard out streams, which we can use for reading and writing data. Let's look at some examples. In this code, we start by creating a mutable string called input to store the user's input. We then use println to display a prompt for the user to enter their name. Next, we call IO standard in readLine to read a line of input from the user. The input is stored in the input string, and any errors that occur during the read operation are handled using the error branch. To remove the trailing newline character from the input, we use the trim method on the input string and assign the result to the trimmed input variable. Finally, we use println to display a personalized greeting to the user, incorporating their entered name. Now let's look at using standard out. In this code, we define a string variable called message with the content hello world. We then use writeln macro, which is similar to the println macro, to write the message string to standard out. The IO standard out function returns a handle to the standard out stream, and the writeln macro writes the formatted message to that stream. By using writeln and IO standard out, we can write data to standard out in a convenient and reliable manner in Rust. Rust emphasizes robust error handling, and the standard result and standard option modules play a crucial role in that aspect. Let's begin with the result type. Rust uses result to handle computations that may succeed or fail. It is often used when performing operations that can encounter errors. In this code, we define a function called divide that attempts to divide two numbers. It returns a result with a success case OK, containing the result, or an error case error with a descriptive error message. In the main function, we match on the result and handle each case accordingly. The standard options module provides the option type, which represents the presence or absence of a value. It is often used when a value can be absent or when handling nullable types. In this code, we define a function called findElement that searches for a target element in an array. It returns an option with a sum variant containing the index if the element is found, or none if it is not. In the main function, we match on the option and handle each case accordingly. These types, combined with powerful combinators and pattern matching, allow you to handle errors and optional values in a concise and a safe manner. The std thread module empowers you to write concurrent and parallel programs effortlessly. Let's explore how it works through a simple example. In this code, we create a new thread using thread spawn, passing in a closure that represents the code to be executed concurrently. Meanwhile, the main thread continues executing its own code. By utilizing join, we synchronize the main thread and the spawn thread, ensuring they complete before the program exits. With REST threading module, you can easily create and manage threads, enabling efficient concurrency in your applications. Whether you need to perform complex calculations, handle multiple client requests, or improve performance, REST threading module has got you covered. The stdnet module enables networking capabilities in your REST programs. It allows you to create TCP and UDP sockets, perform socket operations, resolve domain names, and more. In this example, we create a TCP server that listens on localhost 8080. The handle client function is responsible for handling each client connection. It reads data from the client, prints it, and writes a response back to the client. In the main function, we bind the server to the specific address and port using TCP listener bind. We then enter a loop where we wait for incoming connections using listener incoming. For each new client connection, we spawn a new thread and call the handle client function to handle the client's requests. Once a client connects and sends some data, the server will print the received data and send back a response. That concludes our exploration of the REST standard library. We covered essential modules that help you to create data structures, write and read files, write concurrent code, and enable networking capabilities. To dive deeper into the standard library, I recommend referring to the official REST documentation. If you found this tutorial helpful, please consider liking this video and subscribe to our channel for more exciting programming content. Thank you for watching. If you have any questions or suggestions for future videos, please leave them in the comments below. This is Konstantinas from Programming Journey, signing off. Journey before destination.